Today we're going to be looking at lesson 5.3, Business Sense. And our objective today is, given a story, I can write and solve a system of linear equations in 2 out of 2 problems. So we'll think back to what systems of linear equations were. We talked about that as 2 or more equations in 2 or more variables that are solved together. So we're going to be looking at those today in the context of a story. So good old Carlos and Clarita, we remember them from their lemonade stand. They invested their money. We calculated how much interest they got on their bank account. And they have decided to withdraw their business savings to start a new summer business. They are going to do C&C pet sitting. They're going to watch people's pets while they're out of town. Not only do they have a large unused storage shed where they can house animals, they also have a spacious fenced backyard where the pets can play. So this will be a great opportunity for them to make some money starting a new business in the summer. However, the storage shed is quite a mess. And they've decided to hire professionals to clean and paint it, but they need help figuring out which companies to use. So they're going to compare some companies side by side and see which one is better for their situation. So the first thing they're going to look at is a window cleaning service. So they've got 2 companies here, Sunshine Express window cleaners and Painless window cleaners. Sunshine Express charges $50 for each service call plus $10 per window, whereas Painless window cleaners charges $25 for each service call and $15 per window. So which tools should we use to compare these 2 companies? We have all kinds of tools we've used throughout this year. We've used graphs, tables, equations. What should we use on this one? What would help us figure out the differences here? How about we start with a table on this one? Let's compare these 2 with a table. I'll make some room down here. So if we were to draw a table for this first one, what would our 2 variables we were comparing be? What are our variables in this evaluation of what they're charging? Well, our output is probably the amount of dollars they're going to charge us, right? That's what's changing. That's what we're interested in. And then is there another variable in here that affects how much they're charging? $10 per window. So it sounds like the number of windows is going to affect that. So number of windows is going to be our input value. So we could start with 0 windows, right? That's kind of a silly thing. No one would hire anyone to wash 0 windows. But just to be complete, just to start at 0, how much would we pay if we had 0 windows, but we still called them out? They still charged us the service call, but we had no windows for them to clean. So it'd be $50 plus 0 times 10. So just $50 for 0 windows. For 1 window, it would be that $50 and then $10 for a single window. So 50 plus 10 is 60. For 2 windows, it would be $10 more because we added a window, so this would be 70. We are adding 10 each time. This looks very familiar. Maybe we'd call that an arithmetic sequence. For each window, we add $10. 5 windows, we'd get to $100. 6 windows, it would be $110. So this one is Sunshine. We'll just label it up here so we remember. Sunshine Express. Now let's look at Painless over here, right next to it. Painless windows. We'll draw a table. We'll have the same variables, So this is going to be windows again, and dollars. And we'll do the same evaluation. We'll start with 0 windows. How much would they charge for 0 windows? Well, let's see, it's $25 for a service call, and then 0 on top of that, so just $25. So then, when we have 1 window, we're going to add $15 on, so we will have 1 window. 25 plus 15 is going to be 40, so we added 15. For 2 windows, we're going to add 15 again. We'll get 55. 3 windows, we add 15 again. We get 70. And we keep going in that pattern. Add 15, we get 85. Add 15, we get 100. Add 15, we get 115. Now we can compare these side by side, right? For 0 windows, again, that's silly. No one would hire them for 0 windows. But if we hired them for 0 windows, Painless would cost less than Sunshine, $25 versus $50. So this over here would definitely be better. For 1 window, Painless is still better. That continues to be the case for 2 windows, 3 windows, 4 windows. But look at what happens at 5 windows. At 5 windows, they're the same. They charge the same amount at 5 windows. And after 5 windows, let's see if we did a couple more here. We had 120, 130 versus 130, 145. You can see now Painless is going to cost more above 5 windows. So over here we'll want Sunshine, whereas these ones were Painless. So it depends on how many windows they have in the shed. If they have more than 5 windows, they'll want to go with Sunshine Express. If they have less than 5 windows, they'll want to go with Painless window cleaners. And if they have exactly 5 windows, it doesn't matter. They'll be charged the same amount. So that's doing that with a table. What about with an equation or graphing? We really like graphing systems of equations. That can be really helpful for us. And we already have an answer here, but maybe let's look at a different way we could have solved this. So in order to graph, we can either graph it by hand and graph all of these points, or we can come up with an equation. Now, I like to do an equation because we can put it in Desmos and it'll graph it for us. So let's see if we can remember how we do arithmetic equations from the sequence. We used function notation sometimes. We can use function notation. X was our input, so all these numbers right here are X. And then we had this format, right, that was mx plus b. M was our common difference, remember, the amount we add each time, that was our M. And then our B was our value at 0, So let's see if we can fill that in here. Well, our common difference for Sunshine was plus 10 each time, right? So 10x. And then our value at 0 was 50. And now it makes a little more sense why I had us do a value at 0, because it makes the equation much easier. If we do Painless windows as g of x, we do the same pattern. 15 is our common difference, so 15x. And 25 is our value at 0, add 25. So there are our 2 equations. I'm going to take those 2 equations and put them over in Desmos and see what we get. So here we have those 2 equations in Desmos. And you can see we've typed them in exactly as we wrote them. And by default, it shows us this negative area. Now we said this was number of windows versus cost. And none of those things are going to be negative, right? We don't have a negative number of windows. We're not going to be taking money from the company, so only positive values make sense. We're going to shift this over to just the positive numbers. And you can see we kind of need to adjust our axes to what makes sense for this graph. You can see it's way up here, it's kind of hard to see. So I'm going to adjust my axes using this little wrench. And I'm going to ask myself, how many windows make sense? How many do I want to look at? Well, it starts at 0 and goes up to maybe 20 windows. That would be a lot on a shed, 20 windows, but maybe that's the maximum we want to look at. And the cost, the minimum cost we think would be 0. We pay $0. And then maybe up to like $300. Is that a reasonable amount to pay for window cleaning? So if we adjust our axes like that, now we can see the graph a lot better. We can see exactly where it crosses. We can click there and see, indeed, 100. That is what we found before, right? 5 windows, they both charge $100. But then we can see more on this graph. We can see this blue line is below the red line. So the blue company, that was painless, the blue company is charging us less all the way up through 5 windows. And after 5 windows, the red company, that was sunshine, the red company charges us less. So that agrees with what we concluded before when we were looking at the table. For fewer than 5 windows, we're going to want to use painless. For more than 5 windows, we want to use sunshine. So great work on that one. We figured out which company we should use. We just need to go count the number of windows on the shed. Let's look at another example. So now we're looking at painting the shed. We have paint by numbers and paint it right. Paint by numbers charges $100 for sanding and masking, plus $16 per hour per painting. And Paint It Right charges $24 per hour for labor, plus a $38 waste disposal fee. Now, they're charging different upfront fees for different things, but they both have an upfront fee. And then it sounds like they're also charging a rate per hour. So how might we want to compare these? Do we want to do a graph, a table, an equation, maybe other options? We've done pictures before, maybe that appeals to you. Let's try this one with equations initially. So looking at the equations, we said that we're going to do mx plus b, right? F of x equals mx plus b. M was our common difference, b is our value at 0. So can you see those two values in this setup? $100 for sanding and masking. Well, that sounds like what they charge us without any hours of labor. So maybe that's our value at 0. $100 is our value at 0. And then $16 per hour. So every time we add an hour, we'd add $16, right? So adding $16 each time, that sounds like our common difference. So we'd get 16x here, and then x would be the number of hours of labor. So there's our equation for paint by numbers. Down here with Paint It Right, we'll set up an equation the same way. We'll ask, what is our value at 0? They charge $24 per hour for labor plus a $38 waste disposal fee. So if we had 0 hours, this number would go away. We'd only have $38 left. So at 0 hours, we'd have $38. That sounds like our value at 0. And then our common difference, how many dollars we'd add for each hour? Well, that's 24, right? At 1 hour, we'd add 24. At 2 hours, we'd add 48. So we get 24x plus 38. there are two equations. Now we could solve these, we could graph them, but since we're comparing which one is more, which one is less, I think a graph might be a really great option here so that we can see which one is above and which one is below. So let's head over back to Desmos and type in these equations. So here we are in Desmos again. I've typed in our equations. And again, you can see we're back here with negative numbers. These negative numbers don't make sense. We don't have negative hours of labor. We don't have negative amounts they're going to charge us. So we're going to come up and look only at the positive values. And you can see, again, this is really tall, so we need to change these axes to something that's more reasonable for our problem. So let's see, number of hours we might expect someone to paint a shed. Maybe like 20 hours, is that reasonable? And then how much might we expect to pay to have the shed painted? Well, definitely start with 0. We don't want to pay, we can't pay less than $0, but maybe up to like 300. Maybe that's a reasonable amount to pay for cleaning or for painting. So now we can look at this graph and see right there, they meet at 7.75 to 24. So what does that mean? What do those numbers mean? We said X was our hours of labor, and Y was our amount they're going to charge us. So if our X value is hours, this is 7.75 hours. At 7.75 hours, that's where both companies charged the same amount, which is $224. So which one would you want to go with before that? It looks like our second one is going to charge less before 7.75 hours. And our first company is going to charge less after that time. So it depends on how long it takes for them to paint it. So we said this one, we'd want to do paint it right for less than 7.75 hours. This one up here we use for greater than 7.75 hours. And if it was exactly 7.75 hours, they'd charge the same. Now this one's a little bit trickier though. So how do we measure, or how do we estimate how many hours it's going to take to do this paint job? What different things might we consider? What things can affect how long it takes to paint a shed? Maybe how big the shed is, how much area they have to paint, and how fast their painters are. So that might be something they would want to ask these companies. How fast do your painters paint? How many square feet can your painters paint per hour? And then they could compare that to the size of their shed. They might ask, how many people are on your staff? And do I have to pay each of them by the hour, or is it just paying your team by the hour? We might ask, what kind of paint do you use? And do we have to pay for drying time in between coats? Because you have to do multiple coats for often. You have to often do multiple coats for paint jobs. So all of these things might be things to consider asking these companies when determining which company to use. Now, Clarina thinks it might be a good idea to buy some extra paint supplies in case they ever need to do touch-ups. So they might buy some extra paint, some extra paint brushes. So if they ever get a nick in the paint, they can fix it themselves. And their dad tells them that if they will buy a pack of paint supplies, he will buy a few supplies from them for projects around the house. So they could invest in a lot of paint supplies and he will recoup some of their costs so that he can use those supplies. So here at their local paint store, they have a small paint kit, 2 paintbrushes, 4 rolls of masking tape for $16. And they also have a large paint kit, 5 paintbrushes, 15 rolls of masking tape for $50. And they're asking how much, if they're going to be honest and even and charge their dad just what they paid for it, how much should they charge their dad for a brush? How much should they charge for a roll of masking tape? How might we figure this out? We have all those tools we had before. We could do a table, we could do a graph, we could do equations. Well, let's see. Maybe equations make sense here, because we could set this up pretty easily, right? 2 paintbrushes, maybe we just called that P for the cost of a paintbrush. 2 paintbrushes plus 4 rolls of masking tape, R for roll, equals $16. And then over here we have 5 paintbrushes plus 15 rolls of masking tape for $50. So you see we now have 2 equations in 2 variables. And we've looked at graphing a lot today. Maybe we should try graphing again. Graphing sounds great for these, especially because substitution would require us to solve for one variable, and that might be really annoying with these. We don't have either variable isolated in any of these, so substitution might be kind of difficult to do. Maybe let's put these into Desmos and see if we can figure out the answer. So here we are back in Desmos. I've typed in these equations. Now notice instead of P and R, I've used X and Y. That is necessary in Desmos. It expects X and Y values. So I had to use X for P and Y for R. But otherwise I just typed them in exactly as we did them. Now let's think. P was paintbrushes, so that's our X. That's our cost per paintbrush. And then R, or our Y value, was our cost per masking tape. Do these make sense to have negative values? Nope. Negative values don't make sense, so we're just going to get rid of those negative values and not look at them. And now we can find that these two meet right there at 4,2. 4,2 solves these equations. This is where the value of the brush and the value of the masking tape in both of these kits are the same. So if P was our X value, that means $4 for a paintbrush and $2 for a roll of masking tape. So that is our answer here. $4 for a paintbrush, $2 for a roll of masking tape, because our intersection was at 4,2. So that brings us to today's objective. Given a story, I can write and solve a system of linear equations in 2 out of 2 problems.